Bismillah Rahman Rahim. In this session, we will discuss radioactivity. Uh, this topic is very important for O level and IGCSE students uh, under the subject of O level physics and written. Have taken this material from the book Tom Duncan and Heather Kennett 2021, a highly recommended book for IGCSE and O-level physics and published by Hodder's Education. Uh, Radioactivity was discovered by French scientist Henri Becquerel, and it was very accidental. Uh, what he found that the uranium compound emitted radiation that affects the photographic plate even if it was wrapped in a black paper. So this photographic image that was developing on that black paper, and second, the ionized a gas. So it was uh, creating a photographic effects on the black paper and ionizing ionize a gas. So these two effects was observed or discovered by this Henry Becquerel. So the phenomena of radioactivity was discovered or accidentally discovered. Soon afterwards, Marie Curie discovered the radioactivity element radium. And we know that radioactivity arises from unstable nuclei. Unstable nuclei are radioactive elements and which may occur naturally or produced in reactors. So it may occur naturally or artificially in reactors, and radioactive materials are widely used in industry, medicine and research. So these are the application areas: industry, medicine and research, and many other areas. We are all exposed to natural background radiation, both natural and artificial. So some of the background radiations are cosmic rays that are mostly absorbed in the atmosphere, but some reach to the Earth's surface as well. Radon gas is in the air. Uh, Numerous homes are built from granite rock that emits radioactivity. Radon gas, this collects in the basement or well insulated room if the ventilation is poor. So radons are uh, observed in poor ventilated areas or such basements of the uh, houses. And radioactive potash K40 is present in a food and absorbed by our body. So our body absorbs K40, which is usually present in food. Various radioisotopes are used in certain medical procedures. Radioisotopes are used in medical procedures. Radiation is produced in the emission from nuclear power station. So in the nuclear power reactor, these radiations are produced, and in fallout from the testing of nuclear bombs, later produces strontium isotopes with long half-lives, which are absorbed by the bone. So these are the some natural and artificial background radiations. So radioactivity in the air is this much, cosmic rays this much. So this is the pie chart that shows the radiation sources. And now ionizing effects of radiation. A charge electroscope discharges. So this is a charge electroscope. When lighted match or a radium source held in by forceps is brought near the cap. The charge electrodes. This is lighting match, and it discharges. So it means that there are some charged particles. Note that if the neutral atom gains an electron, it becomes a negative ion. So if electron gets to a neutral atom, then it becomes a negative ion. Similarly, if electrons emits from a neutral atom, this emits, so it becomes a positive ion. So if a neutral atom gets the electron, then it becomes negatively ioned. So Geiger-Müller GM tube, when radiation enters the GM tube, either through a thin end window made of mica, or if the radiation is very penetrating through the wall, it creates argon gas and electrons inside the GM tube, and these are accelerated toward the electrodes like this and cause more ionization, colliding with other argon gas. On reaching the electrodes, the ions produce a current pulse which is amplified. This ionization produces current pulse which is amplified, fed either to a scalar or rate meter. A scalar counts the pulse and shows the total received in a certain time. So this is the mica window, cathode tube, and argon gas are inside, and when the penetration comes here, and this anode, this cathode, this argon gas inside, and when radiations enters here in GM tube, the radon gas, argon gas, it ionizes, and this ionization interacts with other atoms, and as a result more collisions occurs, and the electronic pulses generated that is collected on a scalar or a rate meter. So this is the simple working of a GM tube or Geiger-Müller tube. Contrast correction. Contrast measured from a radioactive source is needed to be corrected by subtracting the contribution from the background radiation from the reading. So whenever a radioactive source are used, we should always subtract the contribution from the background. That is because that radiation is not emitted from that source, but from the background. Instead, it is from the background. So how to count the background? The background count rates in a location can be obtained by recording the count rate well away from a radioactive source. We should take away some radioactive source for a few minutes, and the instruments are placed in that location so that background count rate may be monitored. So some test yourself from page 263 of this Heather Kennett and Tom Deakin books of physics. The two major sources of background radiation as we discussed here. So there are so many sources are discussed here. The background radiation from both natural and artificials are discussed. Cosmic rays, radon gas in the air, radioactive potassium present in the food, various isotopes used in medical procedures, radiation produced in the emission from the nuclear reactors. So these are the sources of radioactivity. What property of radiation is used to detect radioactivity? What property of radiation is used? So ionization effect is used to detect radiation. So and spark counter can be used to detect alpha particles or other particles. So ionization effect is basically used for detecting the radioactivity. A count rate of 190 counts was recorded for a radioactive source. If the background count over 1 minute was 300, calculate the background count rate per second. So This was the radioactive source producing 190 counts per second. Background counts over minute was 300. So the background count 300 counts per minute. So 300 counts per minute means 60 seconds. So the background count 300 divided by 60. So the background count per second is 5. So this is the background count rate in background count rate is 5 counts per second, which is equivalent to 300 counts per minute. So the corrected count rate for the source is 190 from the radioactive source, and this on subtracting this background counts 5, that's the corrected count rate from the source is 185 counts per second. This is very important question. Alpha, beta and gamma radiation experiments to experiment to study the penetrating power, ionizing ability and behavior of the radiation in magnetic and electric fields. So we will discuss this alpha, beta and gamma radiations with respect to penetrating power, ionizing ability and behavior of the radiation in magnetic and electric fields. Show that the show that a radioactive substance emits one or more of the three types of radiations. Radioactive substance produce three types of radiation: alpha, beta and gamma radiation. The emission of radiation forms from a nucleus is spontaneous. So these alpha, beta and gamma radiations that emits from the nucleus is spontaneous. These radiations emits from the nucleus of a atom, and random process is in the direction. So here we have a radioactive source. This is a radioactive source, and this is a lead sheet with 1 mm hole to prevent overloading of GM tube. So we have a small hole here on this cone source. This GM tube will reach this well. Penetrating power of the different type of radiation can be investigated as shown in figure 5.5 by observing the effect on the count rate. By observing the effect on the count rate of placing one of the following in turns between GM tube and the lead sheet. GM tube and the lead sheet. This is the lead sheet and this is GM tube. This source is coming on this GM tube and it observed on the rate meter. A sheet of thick paper and lead and tube must be close together for this part. A sheet of thick papers, a sheet of aluminum 2 mm thick, and further a sheet of lead 2 cm thick will be placed. So the radium emits alpha particle, beta particle, and gamma. If a source emits alpha, beta and gamma, other sources can be used such as americium, strontium and cobalt. A spark counter can be used instead of GM tube to detect alpha particle. For detection of alpha particle, the spark counters can be used. So alpha particle, these are stopped by a thick sheet of paper. So if alpha particles is stopped by a simple thick sheet of paper and have a range in the air of only a few centimeters, it cannot penetrate to a larger distance. They can cause intense ionization. The ionization power is very high in a gas, so due to different collisions with gas molecules, so alpha particle is uh, have a very small penetrating power range, and its ionization power is very intense ionization. It produces very high ionization due to the frequent collision with the gas molecules. They are deflected by electric and magnetic fields because it's a positive charge. Whenever it travels across the magnetic or electric field, it is deflected and in a direction by an amount which suggests that they are helium atoms minus 2 electrons. So this is alpha particle is basically a helium atom minus electrons, 2 electrons. Helium ion with a double positive charge is a alpha particle. For a particular substance, they are all emitted the same speed, about 1/20th of that of the light. So americium is a pure alpha particle source. Americium 241 is a pure alpha particle source used in smoke detectors. Beta particles, they are stopped by a few millimeters of aluminum. Aluminum sheets are placed to stop the beta particles. They have a range in air of several meters. Their ionization power is less than the alpha particle. The alpha particle has the highest ionization power. As well as being deflected by the electric field, they are more easily deflected by magnetic field. So these beta particles are more easily deflected by the magnetic field. A measurement shows that beta particles are a stream of high energy electrons. Beta particles are considered as a stream of high energy electrons emitted from a range of speed to that of light. So their speed range is so high, close to the light. Strontium SR90 emits beta particles only. Note that beta particle is often just referred to as beta particle. Though this is beta is basically a negative. Beta negative particle is often referred to as a simple beta particle. And the magnetic deflection of beta particles can be shown as in figure 5-26. So this is a source and this is a lead sheet, so that this source emits radiation of beta particles. Suppose this is a strontium that only emits beta particles. So this beta emits from here, and this is a magnet. Because of this magnetic field, it deflects. So the GM tube at location A counts less count as compared to B because of this deflection. If we move this GM2 from A to B, the count rate will increase here at this point B, which means that this magnetic effects is causing deflection. Without this magnet, the count will be high at this A locations, but with this magnet placement, after this magnet placement, the more count rate will be observed at location B, at position B. With the GM tube at A and without the magnet, the count rate is noted at point A, and inserting the magnets reduce the count rate. After placing this magnet at this location, the count rate will reduce because it will deflect it to this position. When the GM tube is moved sideways to B, it increases again when the GM tube is moved sideways, like from this position to this position. So gamma emission, the most penetrating and are stopped only by many centimeters of lead. So this gamma emissions have a most penetrating power, penetrations, and stopped only by many centimeters of lead. Leads are used to stop this gamma. Gamma is very difficult to stop, so they ionize the gas even less than beta particles. So ionizing power is very low as compared to alpha and beta. and not deflected by electric and magnetic field. So these gamma radiations are not deflected by the electric or magnetic field. They give interference and diffraction effects and are electromagnetic radiation. So these gamma emissions are the electromagnetic radiation traveling at the speed of light. So their wavelengths are those of very short X-rays. Cobalt emits gamma radiation and beta particle, but it can be converted with aluminum to provide gamma radiation. If the cobalt source is protected with the aluminum sheet, then only at the after aluminum sheet only gamma radiation will be available. On comparing alpha, beta and gamma radiation, alpha particle interacts strongly with the matter. So alpha particle strongly interact with the matter and have a least penetrating power. Its range is so very small, even a thick sheet of paper can stop it. In collision, the large positive charge attracts and easily knock outer electrons from the atom they are passing, leading to the production of ions and giving them the greatest ionizing power. So this alpha particle have a greatest ionizing power, but its penetration power is very least. Even a thick paper can stop it. Beta particle interact less strongly with matter than alpha particles and so have a greater penetrating power. So the beta particle has a comparatively greater penetrating power as compared to these alpha particles, and their single negative charge repels the outer electron from the atom. So this negatively charged when interacts repel the outer electron from the atoms and produces ions, but their ionizing power is less than that of alpha particles. So this beta particle has a less ionizing power as compared to alpha particles. Since gamma emissions are electromagnetic radiation, they have no charge and almost no mass. So they have very small charge and no charge and no mass, and so have a little interaction with the matter. So interaction with the matter is very little, and they have a highest penetrating power. Its range is very high, and they still have sufficient energy to knock an outer electron from an atom and produce ionization, but are least likely to do so. So because of the high energy, it's knock an outer electron from an atom and produce ionization. GM tube detects beta particle and gamma emission and high energy alpha particles. So GM tubes mostly detect beta and gamma emission and few highly energetic alpha particles. So because the range of alpha particles is so small, so GM tubes usually do not detect the alpha particles. So for this purpose, alpha particles charge electroscopes usually detect. Three types of radiation causes fluorescence. So this is alpha particles in a magnetic field. So this alpha particle moves toward this direction. So this is inside the page. So this magnetic field from north to south is shown here, and this alpha particle will move in this direction. So on the opposite side, the beta will deflect, so this direction. The deflection not to scale are formed from Fleming's left hand rule, taking negative charge moving to the right as equivalent to the positive conventional current to the left. So this is the alpha particle, so this is gamma. It will not in the electrostatic magnetic electrostatic field. This is positive and negative plate. So in this electrostatic field, no deflection, alpha particle will move toward the negative electrode and this beta particle will move toward the positive electrode. Because this is a negative charge, so it will attract toward the positive electrode. Since this is positive charge, so it will attract toward the negative electrode. Gamma is having no charge, so it will neither attract to positive or negative, but it simply pass. So the figure 5-27b shows the behavior of alpha, beta and gamma radiation in a uniform electric field. Alpha particles are attracted towards and negatively charged metal plates. Beta particles are attracted toward the positively charged plate like this, and gamma emission pass through undeflected. So which type of radiation from the radioactive materials has a positive charge? Alpha has a positive charge and is most penetration. Gamma, its range is very large and has the shortest range in air. Alpha has a very shortest range. It cannot penetrate to a larger extent. Has a negative charge. Beta has a negative charge. So this is simple answers. Which type of radiation from the radioactive materials is easily deflected by the magnetic field? This beta consists of waves. Gamma is electromagnetic radiations, causes the most intense ionization. Alpha has a very high energy, but its penetration range is very low. It cannot move to a larger distance because its mass is heavy mass, cannot move to a larger extent. So the range is very small. Even a thick sheet of paper can stop the alpha particles. So, and this alpha particle not even pass through our dead skin of our body. So, is not deflected by electric. So gamma is not deflected because gamma is undeflected for a electric as well as magnetic field. So in the next session we will discuss radioactive decay.